Okay, there we go. That should fix that. Got to make the public. Excellent. Okay. A little late, but better than never. So, hello everyone. To everybody here today and to everybody watching this in the future. My name is Connor Marshall, and I'll be running you guys through a basic introduction to Unity involved through the creation of a game. So, just some general information about the course. It'll be a 4-week course every Tuesday at 6 p.m. We'll be going over the basics of different aspects of game creation in each week. So we're just going to focus on one thing a week. So the first week, what we're going to do is we're going to do world, which is just the setup. We're also going to bake in any extra information that our entities are going to need later on down the line. This first week is going to involve no programming whatsoever. It's going to be probably like a bit of a quicker. It's going to be a quicker session than the other two. The other two are probably going to take a little bit longer because there'll be questions about the code and the other things. But this first session, just a very basic overview of the UI in Unity, how to manipulate the camera, both the actual camera that the player sees when you play the game, when you play your game, and the editor's camera itself. Also how to create objects and manipulate them, and just some explanations about the component system that is in Unity. Then on the second week, we're working on the player himself or itself. This will involve movement, the player movement. So if the player presses either the arrow keys or WASD, getting them to move around. And Unity is really nice as well because they have built-in controller support with using the same systems, which is great. Then we're also going to focus on the combat of the player, so the player being able to run around and shoot enemies in the future, but on that week the player won't really have anything to attack. And then finally we're going to work on a stat system for the player. So this is going to affect how fast the player moves, how much damage he does, how much health he has, just general things like that. And then we are going to, then on week 3, we're going to do the exact same thing except with a little bit of a twist, because the enemy that we're going to be working on needs to use the pathfinding data, which is what we set up in week 1. So we'll finally be able to use that information that we baked into the world on week 1. But the enemy that we're going to have is going to be able to have to chase the player around, and in order for the enemy to know where the player is and move to the player's location, they're going to need some form of pathfinding data. And in this instance, we're going to be working with nav meshes, but that's at a later date. Don't worry about that too much. For now, the first session, we're just going to stick with the basics. And then week 4 is like a Q&A session, depending on how many questions we have. If anybody wants me to implement any features and talk them through it, I might also implement some changes to the player system. Like I was thinking maybe there could be like a cool way of doing it where the player could alter their stats in between waves or at some point of the game using our point system, just to give them some more of like a gameplay mechanic. But yeah, so what are the main goals of this course? The main goals of this course is to create a solid platform which you can expand upon as you learn more about Unity, to give you a foundation to create and implement your own ideas, to help teach one of many ways you can tackle large projects without getting lost. In programming, in everything, there is no right or wrong way of doing it. There is just various ways of how efficient you are. And of course, something that's efficient in one instance won't always be efficient in every instance. So learning as many different ways of doing this is really important. That's why the last goal of the course is to help teach one of the ways, just to like help give you guys a better understanding of how you can go about these projects. some final details. We aren't really going to be making anything that looks particularly fancy. We're not going to make any flashy animations, any flashy particle effects, anything like on that level. What essentially we'll be creating is just a pure mechanic-based asset, and assets in their own self, because we want it so that if you take just the player themselves, and you want to use them in a different game, all you have to do is take the code for the player, put it in your own game, and it should work immediately, or as close to plug and play as we can get it. This prevents complications later down the line, or code dependencies. We're going to try to limit that as much as we can. There we go. Just once again, we are creating assets, more than one. So we're going to create the player themselves will be an asset, the enemy the player's fighting will be an asset, and the world itself could be considered an asset, but the main two are the player and the enemy themselves. So what are we making? Let's get right into it. In the spirit of it being October, we are making a first-person / third-person zombie shooter. And the reason why it's third-person / third-person is the systems are very identical in how you go about things, which is why it's quite easy to adapt. So let's go into the details. So this is the first step that everybody should take when they get a project. So what are the main details? What are the main requirements that we need in order to have our game working? So the first detail is the player kills a set number of zombies per wave. There are unlimited waves, or maybe we could change that to like a set number of waves and the player wins, or you could have an endless mode where they just keep going forever. As the waves progress, you can see down there at 2A, player has to kill more zombies per wave. So like the first wave could be 5, the second wave could be 6, and then just continuing on like that. The player loses. Zombies try to kill the player. The player loses when their health drops to 0. Zombies get more difficult to kill over time. Possible zombie variants, but that's going to tie into just how much time we have left on week 3. And that's going to also tie into the zombie stat system themselves, because how we're going to set it up is it's going to be very easy for us to manipulate those stats without having to actually go back in to the code itself, which will help speed up development time a lot. Where zombies get more difficult. Okay, so now we have some of the optional things we can do to the game, and this is purely just if we have time, depending on how, in the player's case, how week 2 goes, and then maybe also how week 4 goes with the questions and answers, but I think I'll move these optional things to week 4. Player has the ability to do extra damage, so like some kind of special ability that they can use where they press a key and then they get double damage for like a minute or so or something, just to like add a bit more, another mechanic to our game. If the player does use it, has to wait some time before he can use it again, aka a cooldown, because we don't want the player just to always have double damage, because then we might as well just make the player just always do double damage. The player can level up stats in between waves. This is like a way of making the player be able to get more on the crazy side and make it more of like a fun little game where like you might be able to jump 2 stories, or you might be able to run like as fast as the Flash. Just something that the player can actually work towards as a goal, which is very important. It gives them some variety and it gives them a variety and replayability in the game. The main components, we're going to be focusing on the world, the player, and the zombies. So now, what the main components that belong to the world themselves is pathfinding data for the zombies. For the player to not fall through the ground, that's always a very good thing. An optional requirement is maybe some areas for the player to hide, like maybe a safe zone where they can rest in between waves, or just somewhere if anybody has played any of the Call of Duty zombies, like they used to be able to funnel zombies through a choke point, something to give more mechanics and more options for the player to try to boost the enjoyment of the game. What are the functional requirements for the player? The functional requirements for the player is it needs a model. In the case of a first person, we need some hands for them to see on the camera. In the case of a third person, we're going to need the body of the player themselves because the camera will be behind them. The stats, what kind of stats the player is going to have, we're going to have a movement speed stat, health stat, damage stat, and then the optional stat, if we get round to it, is the ability cooldown. So maybe over time, the player can slowly try to work that like 2 times damage multiplier down to a lower cooldown so they can use it more often. The other requirements is moves when the user presses WSD or the arrow keys. Unity has a very nice built-in way of doing it. It's one of the advantages of using a game engine to do that kind of stuff. Shoot when left mouse button is pressed, because otherwise the player can't really attack back, and that's not really an interesting game. The zombies need to chase the player. They do damage when they contact the player, just very simple mechanic. We can expand upon it later, or you guys can maybe go out and expand upon it, try to find like another more interesting way of doing damage. The stats, a little bit simpler compared to the player stats, but pretty much the same. And in fact, the stat code should be exactly the same for the zombies as the player, to just help reduce code complexity and code duplication. So we're going to have the health, damage, movement speed. I didn't add the cooldown. The ability cooldown, because I don't think zombies will have an ability. Although that might be something you guys might want to implement on your own time. Take nav mesh data from the world to navigate to the player's location. This is the kind of information that we are going to be baking into the world today, the nav mesh component itself, which is Unity's built-in way of navigating, but I'll explain more on that when we get to that part. Any questions? Nobody else is in chat at the moment, so I think we're just going to get straight into it. If anybody else wants to join later down the line, we can answer some of those questions. So, that's that. So, what we have in front of us here is the Unity Hub. I'm using Unity Hub 2.4.5, but honestly, like, doesn't really matter as long as you're just using Unity Hub. For those of you who need to know what version of Unity specifically we're using, if we go to the installs, we can see I'm using Unity 2020.3.19 F1. But honestly, any Unity version for like the information for the stuff we're doing, anything above Unity 19 will work perfectly fine. We're not really doing anything too intense in terms of the engine or anything like that. So we go back over our projects in the Unity Hub on the left. We can see we can add a project. So this is to add a pre-existing project. We can see all our previous, so these are all my current projects that I'm working on in Unity. I like to play around, so there's quite a few of them. And then we have new project in the top right. We can click this drop down if we have multiple versions of Unity installed, and we can select the version itself. But anything above 2019, 2020, perfectly fine. So we're just going to click new. And this brings us to the Create New Project window. We can choose 2D, 3D, High Definition RP, and then Universal Render Pipeline. Not really focusing on these two. These are a little bit more above what we're going to be doing. 2D can work, and if you guys want to follow along in 2D, it's perfectly fine. Everything should work out pretty okay. If you want to do like more like a top-down game or something, you can start with a 2D. It's just a little bit more specialized, but honestly, like, it doesn't really matter, because once you're in Unity, if you start a Unity 3D project, you can just simply switch it to a Unity 2D. It just changes how your basic layout is. Then what we can do is we can give the project a name. So I'm just going to give it just a random name, and then we can choose the location where to put it. I have my own projects folder for Unity Hub. And then we can click Create. And now this is going to go ahead and create our Unity project. And at the same time, no, actually we don't need that just yet. Just whilst this is loading, Whilst this is loading, it's just importing the packages, opening up Unity. It shouldn't take too long. The newer versions of Unity, this tends to feel a bit slow, but I think that's purely because they added the timer, the busy timer. But nothing too complicated yet. We're just waiting for it to unpack. Okay, so now that we're in Unity, yours might be instead of this nice dark mode, it might be like a day mode. This seems to be a new feature ever since Unity 2022. It seems like it usually launched, because this used to be a paid feature, but I'm not entirely sure why it's been switched like this. Maybe I accidentally activated the trial version, but we'll just keep going with it. So what we have here is we have our general Unity window. Everything that our game uses will happen inside here. And so let's just go through a basic layout of everything. We have our hierarchy in the top left, and this is every component, every object in our game world will be in our hierarchy. And this is also where we can do some UI based stuff as well, but we'll get around to that in a little bit. Then we have our main camera. This is what the player, once they start the game, will see. And we can see that over here in our center screen here, we've got the scene view and the game view. The scene view is the Unity's camera, like the editor's camera, and this is one that we can use to check on other aspects of the world as they're happening without needing to move the player to that location. And then we have the other tab, which is the game window. And this is currently what the player sees. If we click play at the top here of the screen, if I just go back to the scene, if we click play at the top, this will build our code, compile it, check for any errors, and then launch the engine itself. So now our game is running. And right now, that's it. Yeah, we have a functioning game at the moment. So congratulations, everybody. We did it. But we'd like to add some stuff to it, so we're going to just stop. We can also pause the game whilst it's running, just if we want to check some things in the code, or if we want to just switch back to the scene camera and just check up on some things in the game. Not too important right now. So at the bottom here, we've got our projects and our console. This might look a little bit different to you guys. The console window might be like this, and the projects might be expanded. Maybe even looks like these folders. But you can just simply change the size of the folders, the scale, by dragging this bar down here, and then we can just move the console around. I prefer to have the console quite big, because when Unity is quite nice and descriptive with their errors. So it's not too it's nicer to see the full error without having to click on it and then reading the text box down here. Then what we have is our project folder itself, and this is very similar to people who have used Visual Studio Code or Visual Studio or any form of IDE. This is just our current project window. So we can see right now we've got a file called assets, which is the same up here, and inside we have a folder called scene, and scene we have sample scene, which is just this right now. You can think of scenes in a way like levels. Like whenever you go through like a level load, that's essentially loading a different scene itself. But for now, we'll just be focusing on one scene specifically. Then we have our packages. We're not going to be fiddling around too much with this, but these are the default packages that Unity installed when we created this project, and we can access the Unity asset store if we want to install any new packages, or if we want to install any new assets, anything like that. So we'll just focus, for now, we're just going to focus on the asset window itself. Then what we have on the right, we have our inspector, this whole window here. And this is where for each, if I click the main camera, you can see a whole bunch of information just showed up. Every object in this world, so like the camera, the directional light, anything we create in this world will have a transform at the very least. Because Unity needs to know where to place it in the world. If an object cannot have a transform, you see, I can't even remove it. Just make sure I'm not lying. Set properties. Yeah, I can't even remove this transform. But the camera I can remove. See, I can remove the camera component from this, and then that'll turn this main camera into just an empty object, but we'll cover more of that in a minute. But you can see I cannot remove the transform because the Unity engine needs to know exactly where to place it in the world. And this also tells it information about the scale of the object, the size, the rotation, the usual positioning information. We've got tags at the top above that, just under the name of the object itself. Tags are a way of filtering out things later on down the line. Like if you need to find something in code, you can try to find it using a tag. If you're doing a raycast, you can exclude certain tags or only include certain tags. Just a way of like filtering and like separating different objects. So you could have a tag for the floor, a tag for the ceiling, and then in code you'll be able to check which one you're looking at. Layers as well. These can be used for stacking information on top of each other. For just pretty much the same way tags do, except you can put an entire set on a layer itself, and the different objects can use layers or tags differently, or some objects can only use tags and some objects can only use layers. So it just really depends what you're using. But that's a little bit above what we're going to be covering. So this is all nice and all, but we need to move around because we need to start placing things in the world so we can start building our level. We can start building our level out. So to move around, it's quite easy. In the main window, we're going to click on the main window, and then we're going to right click and hold, and then you see we get a little eye icon, and then we can click and drag around, and this is moving the editor's camera, not the player's camera. If I drag both of these side by side, you can see I can move this around, but this isn't moving. A little bit hard to tell, but trust me, it's there. It's doing it. Anyway, and then what we're doing is, whilst we're holding that right click, we can actually use WASD to move around, and this allows us to fly around the world to certain areas. We can use shift to go faster. We can even scroll down to try to make finer adjustments to like how fast the camera is moving. So I can move just a little bit, or I can move really quickly. If I go over here and say I don't know now where the main camera is, like I can click here, I can see it's over there, but say like I don't know where it is, or it's really far away, like over there, and I need a very fast way to get over there. You can, with it selected, you can press F, and that'll center your camera on the object you've selected. So I can center it on the main camera, I can center it on the directional light. So just to go over the what we currently have in the world, we've got the camera and the directional light. The directional light is like, think of it like the sun at the moment. That's how it's currently set up. You can get different kinds of lighting. You can get point lights, spherical lights, box lights, and stuff like that. Or just this directional light. I can change the type here. So you see spot, point, area. So I can change the spotlight here, or I can change it to the directional light. And then using the transform, I can actually rotate these different axes. And by doing that with the directional light, so you think of it like the sun, I'm essentially making the sun rise or sunset. And then say we need to reset this, like we've messed up this kind of information a bit too much, we want it back to normal. We can right click the name of this, which is transform, and we can reset the component, and that puts it back. It sets every value to 0, so we just need to put it roughly back how it was. So now if I want to move this object somewhere else, there's two different ways you can move it. Right now it is in, if we look up here, it's in local position. But what I can do is I can change this to global. Now this is global to this grid. So these arrows are now parallel with these grids. So I can only move it up and down. I can move it back, around. I can also grab these boxes to move it, but it'll only move on that plane. But if I change it to now local again, you can see how they've switched. And this is now relevant to the rotation of the object itself. So if I want to move things at an angle, but in a straight line, then I could use local. But if I want to move them in relation to the world, then I can use global. Cool. I think that's most of the stuff. So let's get on to actually making a little bit of a world that we can move. We can have the player move around in next week. We can save with Control S, just your usual stuff. So what we can do is we can actually, there's two different ways of doing it. One, we can come over here to the hierarchy and we can click this plus, and you can see there's a whole bunch of different things that there's a whole bunch of different options we can pick, and these are all objects in Unity, in Unity's engine. So we can create an empty, we can create an empty child, empty parent, children and parents I'll get onto in just a minute. And then what we can do is we can do 3D objects, we can do effects, lights, audio, video, UI. You notice there's 3D objects, but there's no 2D objects, because there aren't 2D objects, there's UI. 2D works based off of the UI its own. So you can see like a 2D version of a cube will be a sprite. Image. There you go. So you can have like image here. Lighting effect. So it's like an image or a sprite if I can find it, but I think that might be somewhere else. So yeah, image. So, but for now, we won't focus on UI. We're just focusing on 3D itself. If you're following along in the 2D, it's perfectly fine. You can still do 3D. We can just with the camera, it'll look 2D, but it'll be like that nice 2D 3D effect. And the cool thing about doing it that way is you still get dynamic shadows without a lot of effort. Because if you're using sprites and UI elements and images, then it's a lot harder to get those shadow effects. So instead, like if we use 3D, we still get the shadows basically. So we need to create the floor now for the player to stand on, because we don't want the player to just fall through the world. It might be a little bit boring. And so we come over here to the 3D objects, and then we can create a cube, a sphere, capsule. Think of like a tablet you take like a medicine tablet you can take. Cylinder, a plane, which is just a perfectly flat square. Quads, text, ragdolls, terrain. We're not really gonna go anything below quads, I think, is like the most complicated thing we can possibly use in this. The text mesh, the ragdoll, terrain, and everything, that's all other stuff you can use for building the world. We can get into that maybe at a later date, but we're not focusing too much on the visual side of things. We want to be focusing on the mechanical side of things in this course. So I'd recommend starting with a plane. And now you can see this has created a new object in the world, and we have a new object in our hierarchy. And if we look over here to the components of this object, we can see its X, Y, and Z position are a little bit off. So we're just going to right click reset. And this puts it now back straight in the middle of the scene. With a plane, the scale is almost like a cube multiplied by 10 in a way. So you can see this is 1. If I put 10 here, you can see it immediately updates, and now it's all stretched. So we'll just leave it at 1 for a sec, just so I can demonstrate a few things. The other way we can actually create some stuff, because now we have a flat floor for the player to stand on. We want to put some obstacles in the way, something that we can use to make later down the line to make the nav mesh a bit more interesting, to try to improve the enemy behavior, like give them more options. Because right now the enemy will just run face first into the player, which isn't really too entertaining. So then what we're going to do is we will just right click. We'll come back over here. We can right click. Okay. Never mind then. Forget what I said. We're going to go straight back over here into the hierarchy. We can right click and create a new cube. And once again, we can reset its transform. And we can see the scale of things a bit better now. And if I go into the game camera, you can see I've got the objects in front of me, which is good. So the cube is now here, but the problem is it's slightly in the floor, and we can just do a little bit of simple quick maths to figure out, just try to get it placed up so it's no longer clipping on the floor. So we know the cube is a scale of 1, and the plane that we created earlier is intersecting the cube halfway. So we can just simply change the Y position to 0.5. And now you can see the cube is sitting perfectly level. Just some quick things. Nothing too hectic, but we have one cube. And it's all, You know, it's all looking pretty bland. You know, we have a white floor and a white cube. There's nothing really too interesting, and like it looks even brighter when we go into the game mode. Like the light coming off it's quite intense. So let's add some materials to this. So if we come down here to our project window, in our assets, we can right click and we can create a new folder. We can create a new folder and then we can call this material. And then in material, I'm a little bit crazy with the organization, so I'm going to create a new folder and call it world. So now in the world folder, we can right click, and instead of creating a new folder, we can come down to some of the other objects we can create. So we can create 2D, shaders, testing, labels, materials, lens flares, render textures. So this is everything that we can create that we can use in our game, and we can save to the engine itself. There is a way of getting it using the using a folder called resources. There's a way of doing it where we can actually modify data before the game runs, but if we're working outside of the resource folder like we are now with the world, this data won't be able to be changed once the game has been compiled and built. So just keep that in mind. So anything you want to be able to change when the game has been built, put it in the resource folder. Anything that you don't care if it changes, so like in this case, the floor color, we don't really care too much about it changing. So we're going to put it in the normal, like outside of the resource folder. So we're going to come down here, we're going to create a material, and then we're going to give it a name like floor. And now this has done something similar to the editor where we can see essentially just one singular component, because that's what essentially we've made here. We've made something similar to an object, to a component, to like a component style object. And we can see we've got all these different options we can change. All of them are completely different depending on what you use. So this is the options we have for our materials. So since we have a floor material, we can go to the color picker up here at the top, click it, and then this brings up your usual color wheel. And we can change this around. We can just click and drag and move it around, pick a color that we want, but nothing's changing in the world. And that is because if we go to our plane here again, we have nothing assigned. We have a default material assigned to this. So that there's nothing, and we can't change the default material. We can't change it at all. It's grayed out because we can't change it. It's locked. Okay, so instead what we're going to do is we're going to take our floor, we're going to click and drag, and this is the cool thing about Unity. We're going to click and drag and hover it over whatever we want to add this material to. So this is the floor, so we're going to add it to the floor, and you can see now the default material has changed to the floor instead of default material. Now we can come and change this value again, and you can see the value here is changing. But there's an easier way of doing it. If we click on the floor itself, because say we have like a lot of different objects, instead of changing one object at a time, we can come here and we can customize all of the objects at the same time. So I'm just going to pick just a quick color for the ground, so you can see like just a bit of like a palish green. That's our floor setup. Now we have these cubes. This cube is going to represent some kind of obstacle for the player and the zombies to interact with, to either go around or go over. So let's create another material for the obstacle itself. So obstacle, and we can click and drag. So you can see I can drag this onto it, and this will override the floor. But I'm going to drag it onto the cube, and it looks like nothing's happened. But that's because the obstacle material is the same color as the default material. So instead we can make it red, like a bit of a pale red. And now we have two objects in our game. And if we go back over to the game window, it's now no longer as eyesore. It now no longer hurts your eyes to look at. Still nothing too great. The world is pretty bland. So we're going to click on our plane. And then in the scale, we're going to set that back to 10. But we also want to make it so that it's not a rectangle. We want to make it so it's square. A plane doesn't have a Y. You can't really change the Y scale of a plane because there is no Y scale of a plane. You can see I'm changing it up to like 600 now, 500. And in terms of Unity, the units of measurement in Unity, that's also like times another 10 as well. So that's 5,000. That's 5,000 units long, high, but you can see nothing changed. So planes don't have it. Cubes have it. We can make the cube go as high as we want, but planes don't. So instead, we're going to set the z-axis. So now we can see we have a much bigger playing field that we can move around with. We can make some more obstacles. So let's go doing that. Now, it'll be really tedious to keep right-clicking here, click 3D object, create a new cube, take the cube, reset its position, put the obstacle material on it. So instead of doing that, there's a much easier way of doing it. We can just click on the cube itself, and we can just click on the cube itself that we want to change, and we can hold Control and press D for duplicate. Now we've made two versions of the cube, and you'll notice there are two identical versions of this cube. Oops, I've moved you. That's why. So now we have two identical versions of the cube. And we can do this again. We can Control D to make another one, Control D, Control D. Now we've got all different ones. But the cool thing is they're all sharing the same information as the one that was duplicated, as the one we used to duplicate. So it makes quickly setting up something a lot faster than just going right-click, create, right-click, create, right-click, create. Let's just undo all that. Okay, so the cube, quite nice, but let's put what we're going to be using as the player in for scale, just so we can try to get like an idea of the kind of sizes we're working with. So we're going to right-click, 3D object, and we're going to create a capsule. We're going to reset its position, and then this cube I will just move out of the way, so we can see here's a capsule itself. Pretty much the same thing here as well. So we're going to set the Y to 0.5. Oh no, hang on, 1. Capsule is too high, so half of 2 is 1. Quick maths. So now we have our cube, and so this is the rough height of a player in most games. Pretty much almost every single game who's using the average height that is working in Unity is most probably using a capsule to have to represent the player in terms of physics and collisions and other things like that. Of course, like the actual model that you see when you play the game gets put in the capsule's place. And what you can actually do is you can just remove the mesh render from the capsule. And you can see the collision box, which is this little green line here that you can see, this capsule collider. You can see if I can toggle it on or if it goes gray and then comes back. This little green line, this is actually what the physics engine interacts with. Because if it's interacting with this object, there's a lot of vertices and there's a lot of triangles in here to make this a smooth shape. That's a lot for a physics engine to calculate. We want it to calculate, the less we have it calculate, the faster it can run. So instead of having it work off of the mesh, we have it work off of the capsule collider itself. And that's this component down here. And then, of course, like we can edit the things, like we can change like how high we want it. We can make it a ball. We can also change the center position. So if we need to move it, so if I put this back, you can see now the collider is moved. So if I were to hit play now, and I had gravity enabled, essentially this guy would fall through the ground, and then it would stop when it hits this. It would stop when it hits the collider, because this guy doesn't have any collision. This has the collision. Yep. So now that obstacle that we had is looking pretty small, no? So we're going to change it up a little bit as well. But to edit this, like to go like 23, it's like, oh, I don't like 23, so we're going to go 22. That's not really like quite a good way of doing it. Or just that's not really a fun way of doing it, in my opinion. There's a much easier way of doing it. If we look over here in the top right, we've got our different tools that we can use. We have a little grabby hand, which allows us to move the camera around itself. Then what we have is we have our regular transform, which just allows us to move like we've been doing. So we can hop the cube over the player if we want to. We have our rotate, which is what I used earlier to demonstrate the cube. We have our scale. Now this works little bit similar to the transform, but instead of manipulating position, it manipulates scale. And we can click here and drag and stretch it out or shrink it as much as we want to make something a bit more to our liking. And you can see it's updating over here. So if I drag this, you can see now the scale on the X is updating. We need the player. Maybe we can leave that as an obstacle for the player. Let's just move it out of the way a little bit. So I'm going to click the green, which keeps it level with the floor, and move it over there. And then I'm going to press Control D to duplicate, move it over here. And you can see now they're identical again. Let's just set that back to 1, 1. Let's make a little bit more of an obstacle, just like a big wall for the player to run around. So we can put it like that. It's okay that it's clipping through the floor a little bit. That's honestly not too big of a problem. And then we can move this wall over here. We can Shift D to duplicate over there. Shift D, duplicate there. Shift there. Shift D there. Shift D there. And we can see very quickly we've made a little bit of a level for our player to run around. Now, obviously, it's a little bit boring. Like there's not really too much stuff to look around. But this will be pretty good for what we plan on doing. And what we can actually do is we can maybe make one of these a little bit longer like this and a little bit longer like that, just to add a bit of variety and break up the world a little bit. So move it there. So just to break up the world a little bit, add a bit more variety. We can also, if we really want to, we can maybe add some ramps. There's no ramp object specifically in Unity. We can, if we wanted to, we could go into a 3D modeling software like Blender and model a ramp and then import it into Unity, and that would work perfectly fine instead of these models. But we just want to keep it really simple at the moment, so I'm just going to make like a little platform for the player to stand on. And then over here, just Control D again. And what we can do is we can use the rotate and then just rotate it ever so slightly just to make a little bit of a ramp. Control D, duplicate. Down. There we go. A little bit of a lip, not too much to worry about. But yeah, so now what we can do is we can also, it's a little bit straight, so let's break it up a little bit. We can rotate that, rotate this slightly, rotate this. That. Okay, just to break up some things a little bit. And there we go. So we have a little playground to play around with. Now, the last thing we're going to be going over is just baking the navigation mesh that the zombies will be using next week. That the players will be using. Sorry, I don't know what I'm talking about anymore. The last thing we're going to do is bake the navigation mesh that the zombies will be using in week 3. In week 3 to move around. So in order to do that, let's get rid of the player itself, because everything we have right now is pretty much static. It's not really going to be moving too much. So if we look over here in the top right, we have a navigation window. Now, I don't think everybody here will have that. If you don't have it, so if I just close this tab, so if yours looks like this, you can come up here to Window, AI, Navigation, and then it'll look like Agent in the beginning. So think of the agent itself as who is going to be using this information. So in this case, it'll be our zombie. And what we can do is we have humanoid, which is perfectly fine. But if we wanted to add like different variants, we can click this plus here, and then we can add a brand new agent. So we can rename this. No, we can rename this here. So instead we can have it be zombie. Okay, so this is our zombie, who will be using the navigation mesh that we are going to bake into this world. So we have the radius, which is 0.5, the height, which is 2, and the step height, which is 0.4. Now, if you remember that was the same height as our little player capsule. So if I just add another one back in, capsule, and set its position, So we can see the information. We can move this up to 1. If we look at the capsule collider itself, you can see its radius is 0.5 and its height is 2. So if we go back to navigation, 0.5, height is 2, step height is 0.4. Step height is essentially how high your character's legs are. So if I were to actually do this again, and then move this down, you can see I've made a step essentially. So as long as this height here is 0.4 or less, then that means this entity will be able to walk up this, and then this one, and then this one, and it probably won't be able to walk up this one, but you get what I mean. And then we can increase the step height, and we can see the UI changes, and we can even see roughly how high up on the model itself of our entity. So we can see like if he has a step height of essentially his height, which is 2. So now what this means is he can climb up essentially his entire body height. So probably from here to here, he can just step, which might look a little bit weird from a player, because essentially the zombie will just go bloop and just pop up there. So instead what we're going to do is we're going to bring the step height back to 0.4. You guys can play around with this and change it to as much as you want. Not too big of a deal. Once again, remove player capsule. Then we have areas. So this allows us to essentially designate specific areas. So we have walkable, not walkable, jump. So if we have, for say, this wall here, we specifically don't want on top of this wall to be walkable. We can actually mark it as not walkable, and then the AI the pathfinding will know that it can't use that. And then what we can do is we can add users and different weights to things. So if we have like a swamp in one area and a brick road on the other area, the swamp is going to have a higher weight, which means that the pathfinding algorithm is going to prioritize the swamp less. It's going to prioritize the brick road with the lower weight. For anybody who's done something, it's similar to A star in that kind of sense, where it uses it's similar to A star only in the fact that it uses weight to calculate. And then we have our bake options. This allows us to select exactly what we want the world, what information we want to be baked into the world. So we can bake the step height, the agent we want to do, so the radius of the agent. This radius is referring to how close the agent can get to this wall without clipping through it. Then the height of the agent itself, and then the angle. So what we can do is we have it here. We're just going to leave everything default. I'm going to zoom out here. What I can do is I can press F, and that will zoom out after clicking on the world itself. And then I can click bake. Sorry, I forgot one key thing. In object, if I deselect anything, you can see now object is empty. But if I select object, we can see some information has popped up. Now, how Unity's built-in nav mesh works is it has to be pre-baked before runtime. Before your game starts running, this information has to be present. There are ways of doing it where it can be baked dynamically, and then there are other pathfinding algorithms which are better at that. But how this works is a lot of the calculations on the pathfinding gets done now before the game runs itself. And in order to tell the engine that this object will not move, because if we calculate the pathfinding information and then the object moves, then all of a sudden all that calculation went out the window, because they have to recalculate it, and then as it moves again, they have to recalculate, and that gets very intensive. So we're going to tell Unity that this is navigation static, which means it's not going to move. We have promised Unity that this won't move, and in fact, I don't actually think the editor will let you move it in-game whilst it's running. I think like if you try to move it with code, it won't actually work. And then once we tell it navigation static, we can say the navigation area. So we can say this entire green area is walkable. And then if I duplicate this and move it here, purposely leave a little gap, I could say this is not walkable. Okay, and then what we can do is we can click bake. And we can see now this little blue area has shown up, and we can see that the area, it has like a little border. This border is because we told it that the radius of the entity that's going to be using it is 0.5 centimeters. 0.5 centimeters, 0.5 meters, 0.5 units in radius. So it's left, the navigation mesh has left this open so our agent doesn't clip through anything or fall off anything by accident, just as like a bit of a safety net. But it's also not baked this one, because this one is set to not walkable. And it knows, based off of areas, that it's built in, not walkable, doesn't have any form of any, like, Unity knows not to bake any movement information into that one. So in the object as well, we can change this to walkable now, and then we can go back to bake and hit bake, and now we can see it's shown up, which is good. Cool. So now we have our little map. We can delete this one actually, and you can see now I've deleted it, but it's still there. And this is why you can't move a static object or like an object that's had its information pre-baked, because now that it's gone, the AI doesn't care. The AI says, well, you told me I can walk here, so it's going to try to walk there. And what's going to happen? It's going to fall through the ground. So that's not going to work out too well. Next, the next big problem is, well, this navigation mesh, actually we can click bake again, see it goes away now. The next big thing is the navigation mesh really isn't taking into consideration our obstacles. Like if I hide this obstacle by clicking on it, coming back to the inspector, and then clicking this little tick by cube, you can see it's now vanished. It's still there, it's just disabled, and I'll go into disabling and enabling a bit later. We're going to need to know how to do that for our actual zombies themselves. Anyway, so you could see that if I go back to navigation now, the HUD can show up again, and you can toggle it in here, and then you can also show a height map and stuff. So we're in here, but you can see like the information is still there. It's not saying that the AI can't walk through it. So what we have to do is we have to tell Unity that all of these cubes, so we can just click and shift click to select everything. We have to tell Unity that all of these things are going to be static. And we can see a cube, 3 mesh, and 13 others. We have now told Unity that these aren't going to move. And now if we bake, now we can see the nav mesh actually generate correctly. And we can see we have this border around all our little objects, and we have ones up here. So the AI can understand that this is a walkable area. And we can see our little steps here. So this is saying, yep, you can totally walk here, up to here. Make sure, yep. So because this one is lower than our step height, the nav mesh is saying, yep, you can totally walk on that. That's absolutely fine. Same here. This to this is lower than our step height. So you can see the nav mesh is kind of clipping a little bit. If I just disable it, you can see like it's raised up a bit because it's saying, yep, you can totally walk there. That's absolutely fine. But when we come to this tile here, you can say, no, that's too high. That's higher than your step height. You can't walk up there, but once you're standing there, you can walk around. And same here. And then if we over here, our little ramp, because of our ramp height is 45 degrees, and this is less than 45 degrees. We can see the game is going, yep, you can totally walk up here. That's absolutely fine. Now, if I lower the max slope from 45 degrees to, say, 10 degrees and rebake, now you can see the AI can no longer walk up here, because from the game's point of view, this slope is now too steep for them to logically be able to go up. We're just going to set that back to 45 because that's perfectly fine for them to walk up that. And then the same thing for the step height, everything. So that's our pathfinding information done. And if we increase the agent's radius, you can see Unity throws a little warning. Don't really worry too much about that. Just keep it under about, I think, 0.9. And you can see now these expanded. If I change it back to 0, or if I change it back to 0.1, now we're really thin, bake, and you can see we get really close. But we're just going to leave it at 0.5 because that's our basic zombie. Jump distance and drop height. Jump distance is, if I put this back here, bake. A bit closer. Hang on, wait, I need... Right. Here. Trying to find... It's going to be a little bit interesting to demonstrate with what I'm doing now. Okay. Let's try to set up a little scene. So if I have two little cubes here, I bake them. You can see here that these two are connected, but they're not touching, and that's because the jump distance. Hang on, 0. It might just be too close. 0.1, 0.2 bake. Oh, right. Sorry. No, sorry, I'm getting confused now. The jump distance is referring to, okay, so this nav mesh is here and it's cut off with this nav mesh. As long as the jump distance, this gap in between these two nav meshes is less than or equal to this jump distance, the AI can essentially quote unquote jump from here to here. And what it can do is it'll just navigate between these two. It'll essentially, think of it like island hopping. It'll just move to the other island. But for that, that's a little bit above what we're going to be. I just simply, the reason why it did merge is I moved them too close together. So you can see even with the jump distance lower, it's just because I moved them purely too close together. And that's everything. So two more things for us to cover, and then we're pretty much done here for today. So now we've made the nav mesh, we've baked it. This information is being stored somewhere, and it'll be nice if we could access this information, or if we could just see the information itself, if we could maybe have a reference to it in code later on. We need to know where it is. So if we go back to our assets, if we go to our scene, we can see now we have sample scene, which is what we had before, but now there's a new folder called sample scene as well. And in here we can see here is our nav mesh that we just made. So this information here is referring to all these blue little triangles that's on our world. These blue little triangles in our world. And we can essentially save multiple different kinds of nav meshes. Oops, that's not what I wanted to do. Yeah, we can essentially save different kinds of nav meshes depending on different scenes. So this nav mesh now is for this scene. If I had a different scene, I could then bake a different nav mesh for that level. Because remember, the scenes, like the best way to think of scenes are like levels. So like for this level, we could have one set of nav mesh. For the next level, we can have another set of nav mesh. And that allows us to also gain references to them later down the line. And I'll show you how to do that in the next video. But finally, please, let's just clean up some of this mess that we have in our hierarchy, because the hierarchy is everything in the world. So it's going to very quickly, and as you can see, it very quickly got quite cluttered. And we want to be able to clean this up. So what we're going to do is we're going to right click and we're going to create something called an empty. This empty is, remember how I said every component, every object in Unity has at least a transform? An empty is just an object with a transform. It is the most basic object that you can have in the Unity engine. So what I like to use them for, and what other people like to use them for, is little folders to keep information inside. There is one caveat to it though. Well, a few, and then this will come back to parents and children and other things like that as well. So for now, let's create this. So we're going to go world. Okay, so now we've named our new object called world. And of course, like if you go back to the inspector, we can rename it to whatever we want up here. Or we can right click and rename it to see if, just in case we want. There's one little problem. I'm going to demonstrate this problem. I'm going to show you the other way to do it, which prevents this from happening. So if I select everything and move this now into the world. So this works just like a folder. So I've essentially, think of it, I've moved all these files into the world folder. But now if we go back to the world, we can hide all that, and our hierarchy looks a lot cleaner. So nice. But the world, if we look over at the transform, the transform has information in it. It's not centered. So we go, okay, we right click, we reset. And all our stuff gets lifted up in the sky. Because these cubes were at a specific X and Y. And the world was at a different XY. But these cubes were assuming that they were their origin, essentially. Like think of it like an origin point, like a center point for where they started, is at 0, 0, 0. But when we moved them into the world, now it wasn't at 0, 0, 0, it was at where the world was. Sorry, it was still at 0, 0, 0, but the world itself's origin was different. And then when we set the world to 0, 0, 0, it now shifted everything out of the way. Because children inherit from their parents, inherit the transform of their parents. So these cubes, all these cubes here, are the children of the parent world. And I can move the parent world, which in turn moves all the children. And you can see here, I've got negative 52.9, but if I click on the cube, nothing's changed. So you see negative 41. I go back to the world and I move the world here. Where was it? Negative 41, okay? You see how nothing's changed? Because this transform is now working locally in relation to its parent. Which is why it's at negative 41 in its reference frame, which is based off of its parent. So if I set its parent to 0, now it's actually at negative 41. But if I move the parent, it's negative 41 plus what the parent's offset is as well. So negative 41 plus negative 33.1 gives you its actual location. So to prevent this whole ordeal from happening, where because now what's happened is my entire world I've just spent ages building has been shifted and destroyed, and I have to re-put it all back together, and it might not work. Because also now my nav mesh has to be remade, and we don't want to have to do that. So I'm just going to undo to the point where I first moved everything out. And now the first thing you always do is you make sure that your folders, quote unquote, your empties, are at 0, 0, 0. And then what we can do is we can select everything and move it in there, and nothing has moved. Because the origin points of everything is now at 0, 0, 0, and everything is expecting it to be at 0, 0, 0, which means nothing moves, which is great, because now it's plus 0. And then we can hide it, and that's perfect, and we can go one step above it, whereas if I disable this, I disable everything. Because once again, children inherit from their parents. So if I disable the parent, all the children get hidden as well. And yeah, I think that marks the end of it. So we can have different folders. So we can have one folder for the world, we can have one folder for the player, we can have one folder for the zombie, but we'll change this later. Oh, right. Yep, so that's everything I had to cover. So thank you guys for coming to the first session. I hope you guys were able to learn some things. If you have any questions, please let me know. I believe my contact information is in the advertisement. So if you just have any questions, let me know, and I'll be more than happy to help you answer anything. But for now, have a great day, guys. I'll chat to you later.